Hi there, I am Kevin Gruich. I'm filming this as my EECS 498 engine research milestone, showing off the controller I've made so far for supporting it in the SDL using the SDL2 game controller module, and showing what I've done so far and what we're hoping to do. I mean, before we actually start showing off the implementation of it, the main reason I'm chosen to do the controller is because I think it's pretty much actually essential to a working game engine at the end of the day. On one hand, any developer that is making a console game requires controller support at the end of the day. The amount of users plugging keyboards and mice into their Xbox are very low, and to get that market to really allow that for a developer, that's what you need. And the ultimate goal, I think personally, for making a game engine is to expand the options for the game developer to have, to allow them to craft their vision without having to compromise heavily. And then on the other side, it's really about the accessibility for the users. Controllers allow for you to reduce wrist pain. It allows for the use of accessibility-specific controllers, and it allows for just creating a just more relaxed gaming experience, if you ask me personally. Because using keyboard and mouse, that's almost always a requirement to be at a desk and in a chair. But with a controller, you can be on a couch, you can be in a chair if you want, you can be far away from the screen, and there's a lot less wrist pain involved. And to me, it's just a lot simpler and preferable for a lot of experiences, especially ones that are not like very focused on the technical side of things, like say an FPS where you got pinpoint precision aiming or something like that, like Counter-Strike Global Offensive. But that's my thoughts on the matter. But so far, I've already implemented a lot of the controller. We can actually go over here to the input.h, right? So this was an existing singleton class that I had existing for handling keyboard events and mouse events from SDL2. And I added in support for the controller inside here by creating a controller class and then adding a nice little unordered map of controllers. And then we also have a conversion from index to joystick ID because those are the controller's index is not equal to its joystick ID. Apparently the index is relatively unstable. But the joystick ID is what's assigned when the controller is connected, and so we use that to actually find the controller to make sure we have a unique identification for it. And it's a little easy to get those confused because they do come through the same variable sometimes. We got a couple of functions here that we can go through real quick. Okay, so we can initialize right at the start, allowing for some mappings for game controllers, allowing background events just in case you're not focused on the window. That was more so for debugging some things because I found out that the controllers were being created, but the actual pointer to the SDL game controller itself inside my controller class was instantly being destroyed with the way it was set up, which was causing it to recognize all controller add and removal events, but no buttons, which took a long time to figure out. But this is really, could be a setting honestly set in the API. That might be something to do in the future. We check through the controller event, right? If there's adding, removing, button down, button up, and specifically axis motion. So currently that's what's supported is checking buttons in a similar state to how Unity checks its buttons, right? And then also checking axes to get a normalized value from 0 to 1, or 0 to negative, so I guess negative 1 to 1. And we give some open options to the developer through Lua APIs on Lua Bridge. And you can see right here, yeah, the 3 classic get button options, and then we have get axis value by string. Now, these all use string actually, and we're able to do that because we have a conversion map with some really what most people are going to be using. So, you know, left stick X, left stick Y, right stick X. The triggers, interestingly enough, are actually axes because they are analog, and thus they have specific floats being output at each level of how far they are being pressed. And then we have all the classic Xbox controller inputs. And you can just ask for those using these. And if we go back here, we can look at all the actual setup. So yeah, it'll get the controller by ID. So the notable thing here is that the developers are not going to be getting controller by ID. They don't really know the joystick ID, and it's not really their pain to deal with. They're going to be getting it by index. They want to know who's controller 0, 1, 2, 3, 4. And to do that, we sort of shield them against it, and we save who's in what index at what time, because it can change mid-game. In fact, we have support already for the hot swappable controllers. At the very least, with the current setup, you can unplug. Obviously you can't play while the controller's unplugged, and then plug it back in, and then right back to it. And as far as Lewis knows, there was a controller 0 there, then there wasn't, and then there was again, and it works out. And then over here, add controller, right? We obviously create the class we have, and then remove controller handles it and erases it once it's been unplugged. And so the controller itself is a class for getting the buttons, axes, and managing the button states especially. So we do have support for all possible axes on the controller, but only returning the ones that are actually on the controller with any actual values. Because we can see right here, we have a nice little function to go through and actually print out what the supported capabilities are on the controller when you plug it in, just for debugging purposes. And aside from that, we just have the same functions that we're actually giving to the end user, the checking what string to button, string to axes, getting what the axis value is. And so right here you can see we actually use a dead zone, and that means that there's a minimum amount of movement required on an axis for it to be to register as outputting something. And this is obviously modifiable. Maybe it should be settable by the SD in the Lewis interface. But for right now, it's just defaulted to 8,000, and the maximum possible value for the actual axis is around 33,000. And this sort of prevents like classic joystick drift, and allows for making sure just like a slight wiggle of the controller isn't causing input. But in the future, it would be good to actually modify that so it's settable by the developer. Okay, so let's actually show some demonstrations here. Now I will start my camera to show that my controller input is not hacked. It is not fake. I swear.
Okay. Mission start!
So we can see the log right down at the bottom, all the axes coming in. You can see if I wiggle it quickly here, it's actually pretty much no movement, right? If I start moving around, we're good. And then I can start holding right trigger to shoot, and that's actually using the axes as well, right? We can see on the log that that's actually axis 5. Axis 0 and 1 are on the left stick, 2 and 3 on the right stick. And then the other thing here is you can see that actually I have to hold it down more than 0, not just because of the dead zone, but because in the blue programming, I said it requires 50% press to start shooting. And it also works that if you press A, it will also start shooting. So that also just shows off the button capabilities. You can see that button's back. Supports other buttons like, pressing down the thumbsticks and such. Okay, so let's see if I can show this while playing. I am going to unplug the controller.
Game over.
Okay, we can run it again, but you see suddenly the controller input is all coming right back down here, as if nothing changed. And just for a moment while it was actually unplugged, we get all these nil values. Which that's just because I am not checking for null on the controller at all. While because I'm a bad Lua programmer. I admit it. Okay. So if we take a look at the actual Lua here, you can see I converted the keyboard control from the end of Homework 7, the last test suite, and I converted this into utilizing my new Lua API stuff for the controller, and it'll just get controller 0 just to set as a default.
And over here in done, right, it has that checking the right trigger for being greater than 0.5, and also getting that A button I mentioned. Okay. So this is all working great. It just shows off the API functioning properly. Now, the API is not that extensive yet, and that is one thing I want to improve coming forward. So for next week, stuff I want to test, especially improve on, number one, I want to test actually and make sure that multiple controllers are working. I have my PS5 controller right here. The reason I didn't do much with this week is because it actually has some weird issues with Windows. If you use a DualSense on Bluetooth on Windows, it recognizes it as a generic controller, but still recognizes a lot of its actual inputs. So like the touchpad and stuff still does things. Windows just refuses to notice it, but like Steam and whatnot works fine. It knows it's a DualSense. So I want to experiment with the DualSense and the Xbox controller simultaneously, making sure that obviously multiple controllers work. And then also I want to see about hot swapping the different controller types for the same port. But also especially I want to implement, I don't know if gyroscopic options are, they gotta be in the SDL, I imagine. I would like to look into allowing the Blue API to get gyroscope information. Because I think that's sort of a classic thing with especially DualShock controllers, starting back at the 6-axis on the PS3. And then secondarily, I really want to look at the getting the touchpad right here functional. Because I think that'd just be really cool, honestly. I know it has its own special setup entirely as a controller in the SDL. And yeah, making sure it's just properly supported. Beyond that, I want to add in some of those setting constants, like I mentioned earlier, like setting dead zone as the developer pleases. And I would like to add support for PlayStation buttons. Right? Like if I don't know exactly how to go about it. I have to look more into it. Because right now, it is utilizing mostly the Xbox, not direct input, input, X input, sort of method of things, because it's using XB, XY, AB, XY, and then just sort of standard like PALs, and it's even got specific PALs for the Xbox Elite, an odd thing I didn't know about. But so all that functions, and I just want to add support for easy switching of porting games for a developer, so that they don't have to worry about it necessarily. Could even add support for like displaying what the key is, right? Like a small graphical image, because that's a common issue. It's common sort of something you'll see in a lot of games, right? You'll press a key suddenly on a PlayStation controller, and it'll switch the interface to using PlayStation, saying press A for this, and then suddenly it'll say press X. Right, so I think adding support for that would be really beneficial. But that's all I have for this week, just sort of relatively bare bones support. I don't know if I showed off the capabilities.
Mission start!
But you see after the game starts, it will print off all the buttons it supports, along with the axes it supports, right here, which it supports all of them. Alright, well thank you for watching. Bye.